SIR Model 10 was a vacuum tube, transistor and electronic relay-based computer developed at IBK Vinca and the Mihajlo Pipin Institute, Belgrade, in 1960. 1-2 It was the first digital computer developed in SFR Yugoslavia, and in southern Europe. SIR 10 was designed by Tihomir Elksic and his associates, Rajko Tomovic, Vukasin Masnikoza, Ahmed Mancic, Dusan Hristovic, Petar Vavac and Milojko Maric, and was developed over 4 years. The team included 10 engineers and 10 technicians, as well as many others. After initial prototype testing at Vinca and a redesign at the Pipin Institute, it was fully deployed at the Tanjug Agency building and worked there for the SKNE from 1961 and the Yugoslav government's SIF, from 1963 to 1967. The first SIR 10 system was located at the SKNE, Federal Secretary of Internal Affairs, building in 1961, which would later belong to Tanjug. The Pipin Institute donated the computer's case and some parts of the SIR 10 along with its documentation to the Museum of Science and Technology in Belgrade in March 2006, where the computer's CPU is now displayed. Specifications: 1750 vacuum tubes, 1,500 transistors, 14,000 germanium diodes. Magnetic core primary memory, 4096 of 30-bit words. Secondary memory, punched tape. Capable of performing min. 1,600 additions per second. SIR, Serbian, Digital Electronic Computer, Model 22 is a transistor-based computer developed by Mihajlo Pipin Institute, Serbia, in 1967 to 1968. It was originally intended for banking applications and was used for data processing and management planning in banks, trade and utility companies in Belgrade. 3 SIR 22 computers were purchased by Bobanka, Jugoptrol and BVK Belgrade companies. The principal designers and chiefs of the project teams were Dusan Hristovic, Svetom Rojdanic, Vaslan Potic, Radivolic et al. For Bobanka, Dr. S.C. Miroslav Djokovic, Bruno Lipozavic, Michael Savikin, Ljubovo Markovic et al. For Jugoptrolko, Vladislav Pornovic, Milos Marjanovic, Petar Vavac, Dragiza Dinkovic et al. For BVK Belgrade. Technical characteristics of the SIR 22. Technology, IC, MSI, transistor and diode logic circuits. Printed circuits boards with the ribbon connectors. CPU performance, the 16-cycle instructions, 10 microseconds. Magnetic core memory, 32 kilobytes capacity, memory cycle time of 2 microseconds. Disk storage CDC 854, max 8 disk units. Card reader and puncher, 300 cards per minute and 150 cards per minute. Paper tape reader and puncher, type facet, 1000 characters, S and 150 characters /S. Parallel line printer, type DPMZ4, 128 characters, line, 600 lines per minute. HRS 100, Hybrid Computer System, was a third-generation hybrid computer developed by Mihajlo Pipin Institute, Serbia, then SFR Yugoslavia, and engineers from USSR in the period from 1968 to 1971. 3 systems HRS 100 were deployed in Academy of Sciences of USSR in Moscow and Novosibirsk, Akademgradok, in 1971 and 1978. More production was contemplated for use in Czechoslovakia and German Democratic Republic, DDR. but that was not realized. HRS 100 was invented and developed to study the dynamical systems in real and accelerated scale time and for efficient solving of wide array of scientific tasks at the institutes of the AS of USSR, in the fields, aerospace nautics, energetics, control engineering, microelectronics, telecommunications, biomedical investigations, chemical industry etc. HRS 100 was composed of digital computer, central processor, 16 kilowords of 0.9 ms 36-bit magnetic core primary memory, expandable to 64 kilowords, secondary disk storage, peripheral devices, teleprinters, punched tape reader, punches, parallel printers and punched card readers, multiple analog computer modules, interconnection devices, multiple analog and digital peripheral devices, central processing unit. HRS 100 has a 32-bit TTL-MSI processor with following capabilities. 4 basic arithmetic operations are implemented in hardware for both fixed point and floating point operations. Addressing modes, immediate, literal, absolute, direct, relative, unlimited depth multi-level memory indirect and relative indirect. 7 index registers and dedicated index arithmetic hardware. 32 interrupt channels, 10 from within the CPU, 10 from peripherals and 12 from interconnection devices and analog computer. Primary memory. Primary memory was made up of 0.9 ms cycle time magnetic core modules. Each 36-bit word is organized as follows: 32 data bits, 1 parity bit, 3 program protection bits specifying which program, operating system and up to 7 running applications has access. CE-Model 12 was a third-generation digital computer developed by Mihajlo Pupin Institute, Serbia, in 1971 and intended for business and statistical data processing. However, the manufacturer also stated, at the time, that having in mind its architecture and performance, it can also be used successfully in solving wide array of scientific and technical issues. Computer SIR 12 consisted of multiple modules connected via wire wrap and connectors. Central unit. Primary memory. Type, magnetic core memory. Capacity, up to 8 modules, each consisting of 8 kilowords, 1 word equals 4 8-bit bytes. Speed, cycle time, 1 ms, access time 0.4 ms. Arithmetic unit contains 32-bit accumulator register, 2 separate groups of 8 2-byte index registers, single byte adder supporting both binary and BCD addition. Same unit is used for subtraction, multiplication and division had to be implemented in software. Control unit contains a program counter and instruction registers. It fetches instructions and facilitates program flow. It supports single operand instruction set and works with all 16 index registers of the arithmetic unit. Interrupt system of SIR 12 consists of a number of dedicated registers and software. It supports up to 32 interrupt channels. Control panel of SIR 12 allowed the operator to control and alter program flow and auto-eliminate errors detected by error detection circuitry. It features a number of indicators and switches. SIR 203. SIR, Serbian, Digital Electronic Computer, Model 203 is an early digital computer developed by Mihajlo Pupin Institute, Serbia, in 1971. It was designed to process data of medium-sized businesses. In banks, for managing and processing of accounts, bookkeeping, foreign currency and interest calculations, amortization plans and statistics. In manufacturing, for production planning and management, market data processing and forecasting, inventory management, financial document management and process modeling. In utilities, to calculate water and electricity consumption, to produce various reports and lists, and for technical calculations and design. In construction industry, for network planning, method design, financial management and bookkeeping. In trading companies, for payment processing, market analysis, inventory management and customer and partner relationship management. Specifications. Central processing. Type, BMS 203. Number of instructions, 32. Performance. 1 16-cycle instruction, 20 ms. 1 single-cycle instruction, 5 ms. Addition and/or subtraction of two 15-digit numbers, 20 ms. Primary memory. Capacity, 8 kilowords. Speed, cycle time, 1 ms. Complete, autonomous memory error checking. Parity control. Punched tape reader. Dielectric-based reading. Speed, 500 to 1000 characters per second. Accepts 5, 7 and 8 channel tapes. Tape puncher. Speed, 75 characters per second. Parallel line printer 667. On-the-fly printing. 128 characters per line. Removable, replaceable printing cylinder. Speed. 500 lines per minute for a character set of 63 characters. 550 lines per minute for a character set of 50 characters. Automatic paper feeder. 2-line spacing settings. Programmatic tape for discontinuous paper movement. Maximum number of carbon copies, 6. Independent printer M30. 132 characters per line. Speed. Prints 25 alphanumeric characters per second. Prints 33 numeric characters per second. Tabulation speed, 144 characters per second. Blank printing speed, 100 characters per second. Maximum number of carbon copies, 6. Magnetic cassettes 4096. Capacity, 600,000 characters. Variable record length. Transfer rate, 857 characters per second. Tape speed, 10 inches per second. Magnetic tape drives. Data format, 9-track ASCII with entire record space of 0.6 inches, 1.524 centimeters. Data density, 556 800 bits per inch. Capacity per tape, circa 10 million characters. Tape speed, 24 inches, s, 150 inches, s fast forward and rewind. Transfer rate, 19.2 kHz. Tape width, ½ inch, 1.27 centimeters. Tape length, 2,400 feet, 731.52 meters. Working ambient temperature range, 5 degrees Celsius to 40 degrees Celsius. Relative humidity, up to 80%. Integrated circuit control logic. Separate control panel for each drive. Read, write capabilities. Read and write forward. Read forward. Read reverse. Galeb, N. Seagull, was an 8-bit computer developed by the Pilvarazdan Company in Yugoslavia in the early 1980s. A grand total of 250 were produced by the end of the summer of 1984, before being replaced by ORAO. Galeb was designed by Miroslav Kosijan and inspired by CompuKit UK 101 and Ohio Scientific Superboard and Superboard 2 computers that appeared in the UK and USA in 1979 and were less expensive than Apple II, Commodore PET and OTRS-80 computers. The code name YU101 was chosen to resemble CompuKit's UK 101. Galeb was very similar to computers that inspired it. Specifications: CPU, MOS Technology 6502. ROM, 16 kilobytes, with basic interpreter and machine code monitor. RAM, 9 kilobytes, expandable to 64 kilobytes. Keyboard, 59 keyquarts. I/O ports, composite video and RF TV out, cassette tape interface, DIN5, RS232, D25, edge expansion connector. Sound, single channel, 5 octaves. Graphics, monochrome, 96 by 48 pixels. Text mode, 16 lines with 48 characters each. Price, 90,000 dinars, in 1984. The Galaxia, Cyrillic, Galaxia, meaning galaxy, was a build-it-yourself computer designed by Voja Antonic. It was featured in the special edition Rukunari Vasage Kusi, Computers in Your Home, written by Dijan Ristanovic, of a popular eponymous science magazine, published late December 1983 in Belgrade, Yugoslavia. Technical specifications: CPU, Zilog Z80A 3.072 MHz. ROM AO1-4 KB, 2732 EPROM, contains Bootstrap, Core Control and Galaxia Basic Interpreter code. ROM BO2-4 KB, optional, also 2732 EPROM, additional Galaxia Basic commands, assembler, machine code monitor, etc. Charactrum -2 KB, 2716 EPROM, contains character definitions. Characters are 8 by 13 pixels. The block graphics were vertically divided in a 4:5:4 scheme, and horizontally in a 4:4 scheme. RAM, 2 to 6 KB of 6116 static RAM in base model, expandable to 54 KB. Text mode 32 by 16 characters, monochrome. Pseudographics, 2 by 3 dot matrix combinations in graphic character subset, 64 by 48 dots total. Sound, none according to specifications, but tape interface was occasionally used as audio output port. Storage media, cassette tape, recording at 280 bits per second rate. I/O ports, 44-pin edge connector with Z80 bus, tape, DIN connector, monochrome video out, PAL timings, DIN connector, and UHF TV out, RCA connector. Orao, N. Eagle, was an 8-bit computer developed by Pel Varazdin in 1984. Its marketing and distribution was done by Velobit Informatica. It was used as a standard primary school and secondary school computer in Croatia and Vojvodina from 1985 to 1991. Orao, code-named YU102, was designed by Miroslav Kosijan to supersede Galeb, code-named YU101. Specifications: back of the case, with connectors. CPU, MOS Technology 6502 at 1 MHz. Read-only memory, 16 kilobytes, with basic interpreter and machine code monitor. RAM, 16 kilobytes, expandable to 32 kilobytes. VRAM up to 24 kilobytes. Graphics, monochrome 256 x 256 pixels, in up to 8 shades of gray. Text mode, 32 lines with 32 characters each. 72 chars in one basic line. Sound, single channel, 5 octaves through built-in loudspeaker. Computer keyboard, 61 keyquarts. I/O ports, video and RF TV out, cassette tape interface, DIN5, RS-232, D25, edge expansion connector. Peripherals, 5.25 inches floppy drive, printer. Price, 55,000 dinars planned but increased to 80,000 during production. The TIM-100 was a PTT telemicrocomputer developed by Mihajlo Pipin Institute, Serbia, in 1985. It was based on the Intel microprocessors types 80 by 86 and VLSI circuitry. RAM had capacity max 8 MB, and the external memory were floppy disks of 5.25 or 3.50 inch. Multi-user, multitasking operating system was real-time NRT and also Tranos, developed by PTT Office. PCOM32 and PCOM64, an educational and/or home computer developed by Elektronsko Industrianis of Serbia in 1985. LPA 512 was an industrial programmable logic controller, a small, portable computer developed by the Ivo Lola Rybar Institute of Serbia in 1986 as an enhancement to its prior product, PA 512. It was first deployed in the Maribor car factory. TIM-600 was an important PC computer system of the series of the TIM microcomputers, from Mihajlo Pipin Institute Belgrade, developed 1987 to 1988. It was based on the Intel microprocessor types 80386 and 80387. It has word length of 32 bits, basic cycle time of 20 MHz and operating system Unix v.3 computer system. TIM-600 was exposed at the Munich International Computer Exhibition on September 1988. System specifications. TIM-600 architecture was based on 3 system buses 32, 16 and 8 bits respectively. CPU performs 5000.000 simple operations per second. Primary memory RAM had 8 by 2 MB capacity max. There were the 8 TIM terminals or other equipment units max. Connected by RS-232C. Centronics types interface used for the line printers. Also, there were possibilities for the connections of 2 hard disks as well as the magnetic cassettes and diskettes. Software. TIM-600 uses the programming languages C++, Fortran, COBOL, BASIC, and Pascal. Database management was performed by Informax and Oracle Software. Applications. Computer system TIM-600 was used for business data processing in many offices in Serbia, for example, in public, health, and scientific organizations, for process automation in industrial production, in road traffic control, in some banks, for military and government services, etc.